Picture this, you're staring at the moon on a clear night, its silvery glow casting shadows across your backyard. It's serene, familiar, almost comforting. But what if I told you that hidden beneath its surface lies a mystery so bizarre, it's got scientists scratching their heads and nations racing to claim a piece of it? Hi, I'm Chala Nguyen, and today we're diving into a cosmic enigma at the moon's south pole, a place where a massive metal object, water ice, and a potential $4 trillion treasure are sparking a new space race. Buckle up, because this story is wild, and by the end you'll never look at the moon the same way again. Let's go. The moon has always been humanity's closest cosmic neighbor, just 384,000 kilometers away, a 3-day trip by spacecraft. But its south pole, that's a whole different beast. This region is one of the least explored parts of our solar system, and for good reason. It's cloaked in darkness, with craters that haven't seen sunlight in billions of years. In 2011, NASA launched a mission called Grail Gravity Recovery and Interior Laboratory to map the moon's gravitational field. Think of it like an X-ray for planets. Dense materials like gold or uranium pull harder than lighter ones like manganese, and a thicker crust means more mass, more gravity. In 2019, researchers at Baylor University in Texas were poring over Grail's data when they stumbled on something jaw-dropping in the South Pole Aken Basin, the largest known impact crater in our solar system. This beast is 1/600 miles wide, big enough to swallow half the United States, and over 5 miles deep, roughly the height of Mount Everest. Scientists believe it formed when a city-sized asteroid slammed into the moon billions of years ago. But here's the kicker: buried beneath this crater is a colossal lump of metal so massive it warps the moon's gravity. We're talking something 5 times the size of Hawaii's Big Island. That's not just a rock, it's a cosmic anomaly. Now let's pause and think about this. The moon formed 4.5 billion years ago, likely from debris after a Mars-sized object hit Earth. It's not exactly a metal factory. So where did this giant metal blob come from? The leading theory is that it's the core of the asteroid that created the Aken Basin. Imagine a metallic asteroid rich in iron and nickel crashing into the moon and embedding its heart deep underground. It's like a fossil from the solar system's violent past, preserved for billions of years. But why does this matter? Because this discovery isn't just about science. It's about power, resources, and the future of humanity. Let's zoom in on the South Pole itself. Unlike the moon's familiar face, this region is a shadowy, alien landscape. The moon's axis is tilted so sunlight hits the South Pole at a shallow angle, leaving some craters in perpetual darkness. These aren't just dark, they're among the coldest places in our solar system, dipping to 240 degrees C, colder than Pluto's surface. NASA's animations show how sunlight dances around these craters, never penetrating their depths. It's eerie, like a cosmic void. But these dark craters hold a game-changer: water. Over billions of years, the moon has been pummeled by asteroids, some carrying ice. When these asteroids hit, most of the water vaporizes or escapes into space. But in the South Pole's cold traps, a tiny fraction survives as ice. In 2009, NASA crashed a probe into the Cabeus crater and found that 5% of the ejected material was water. That's huge. Scientists estimate billions of metric tons of ice could be locked in these craters, enough to sustain a colony. Why is water so critical? On Earth, we take it for granted, but in space, it's liquid gold. You can drink it, grow food with it, or split it into oxygen for breathing and hydrogen for fuel. Imagine a lunar base where astronauts mine ice from shadowy craters, power it with solar panels on sunlit peaks, and create a self-sustaining outpost. That's the dream, and the South Pole's unique combo of ice and sunlight makes it possible. Now, let's tackle the big question. Could there be life on the moon? Water is often called the key to life, and with ice in these craters, it's tempting to imagine microbes hiding in the shadows. But hold off on joining that moon-worshipping cult. The moon is brutal. Its atmosphere is a near vacuum temperature swing from 121 degrees Celsius to 130 degrees, and radiation from cosmic rays would fry most organisms. The shadowy craters get slightly less radiation, but not enough to make a difference. Consider tardigrades, those microscopic water bears that can survive extreme conditions. Even they need water to stay active. Without it, they enter a dormant state, essentially pausing life. In the moon's craters, any tardigrade would be frozen solid, unable to repair radiation damage. There's a fascinating exception. Fungi found in Chernobyl's nuclear reactor thrive in radiation, but even they'd struggle in the moon's extreme cold. The consensus, life on the moon is a long shot, likely limited to dormant microbes hitchhiking on asteroids destined to die in this hostile environment. If life isn't driving us to the moon, what is? Enter the new space race, and it's not just about bragging rights. In 2027, NASA's Artemis 3 mission plans to land humans on the moon for the first time since 1972, targeting the South Pole for a permanent base. But they're not alone. China's Chang'e 7 mission, set for 2026, will drill into South Pole craters to test colony viability, with plans for a base by 2030 backed by Russia. Both sides want the same lunar real estate, and the stakes are sky high. The 1967 Outer Space Treaty says no nation can own the moon, but it doesn't stop them from setting up shop and claiming territory. NASA's Administrator Bill Nelson warned in 2022 that China could try to lock down lunar sites, comparing it to disputes in the South China Sea. It's a geopolitical chess game with the South Pole as the board. Why? Because a colony there could be self-sustaining thanks to water ice and solar power from peaks of eternal light ridges that get sunlight 90% of the time. So why are nations so desperate to plant flags on the moon? One word: helium-3. This rare isotope, scarce on Earth but abundant in the moon's regolith, is a holy grail for fusion energy. Fusion promises clean, limitless power, and helium-3 is its ideal fuel. 1 ton could generate 10 gigawatt years of energy, worth $3.5 billion. The moon's estimated helium-3 reserves a staggering $4 trillion. Whoever controls this resource could dominate Earth's energy market. Let's break this down. Fusion reactors are still decades away, but the potential is massive. Helium-3's value comes from its efficiency and low radioactivity compared to other fusion fuels. Mining it would involve scooping up lunar soil, heating it to extract the isotope, and shipping it back to Earth. It's not easy, but the payoff could reshape economies. The South Pole's water and power make it the perfect spot to start. As we wrap up, let's reflect. The moon's South Pole is more than a scientific frontier. It's a mirror of human ambition, greed, and hope. From a mysterious metal blob to ice-filled craters and helium-3 riches, it's a place where our dreams of exploration clash with our thirst for power. The lesson: the moon challenges us to balance competition with cooperation. If we rush in blindly, we risk turning a cosmic wonder into a battleground. But if we work together, sharing resources and knowledge, we could build a future where the moon is a stepping stone to the stars, not a prize to be hoarded. So next time you gaze at the moon, don't just see a pretty light. See a world of possibilities and a test of who we are as a species. Thanks for watching, and if you enjoyed this deep dive, hit that like button, subscribe, and let me know in the comments what's your take on the lunar race. Until next time, keep looking up.